Hi, imagine a future hospital room. Instead of attaching sensors to a patient body, doctors can monitor breathing and heartbeat using wireless communication signals. These signals bounce off the patient's chest and allow the system to detect any movement. This technology actually is part of a new version for future wireless network called integrated sensing and communication, where the same wireless signal can both transmit data and sense the environment. This makes the system more efficient and enable applications like contactless health monitoring as shown in left diagram of this slide. But it also introduces a surprising risk because sensing device can observe the wireless signal. They may also be able to decode the communication data carried by that same signal. In other words, a device designed to observe the environment could unintentionally, become an eavesdropper. So traditional security methods rely on encryption at higher network layers, but wireless signal, still propagate through space, meaning anyone nearby can receive them. So the question becomes, how can we design wireless system that sense the world without leaking the information they carry? Our solution uses something called an intelligent reflecting surface, as shown in this diagram. You can think of it as a programmable world made of many tiny elements that can control how radio waves bounce. By carefully designing how each element reflects the signal, we can shape how the signal appears in different directions, as shown in this diagram. You can see the legitimate user can receive clear and easy to code information, but in other direction, the signal becomes scrambled and distorted. So while the signal still exists everywhere in space, only the intended receiver can interpret it correctly. It's a bit like speaking clearly to one person while everyone else hears only a confusing echo. But designing such a surface is extremely difficult since each small element on the surface can change how the signal reflects. When we combine hundreds of elements together, the number of possible parameter configuration become extremely large. Training them one by one would be practically impossible. So instead of manually designing the surface, we let AI help us search for good solutions. We address this challenge using a generative AI method called generative flow network, as shown in this slide, or GFLowNet. Instead of searching for a single best design, GFLowNet can learn how to generate many high-quality solutions. They explore the enormous configuration space step by step, gradually learning which surface pattern produce strong communication for legitimate user while disrupting signals in other direction by utilizing the neural network. Over time, the model becomes more likely to generate design that achieve both goals, clear signal where we want them and scrambled signal everywhere else. Our results show that this approach can discover high-quality surface pattern using only a tiny fraction of all possible configuration. At the same time, it improves communication and sensing performance while significantly reducing the information the eavesdropper can recover.